This video is all about solving absolute value equations. First, we need to know what absolute value is. So our technical definition is that for any real number a, if a is positive or 0, the absolute value of a is a. If a is negative, the absolute value of a is the opposite of a, which kind of sounds a little confusing. So maybe if we look at it with symbols, for any real number a, the absolute value of a equals a, if a is greater than or equal to 0. If a is negative, the absolute value of a would be negative a, if a is less than 0. That might help a little bit. You should recognize these bars some. For an actual example, let's say we do the absolute value of -3. So for some, we just look at this, we say it can't be negative for my answer, so I'm just going to say it's 3. Another way to remember what absolute value is that it's the distance from 0 on the number line. So I could have also asked you for the absolute value of 3, which would fall into that greater than or equal to 0 or that positive number, so it's just 3. So both answers gave me 3, because if I look at -3 and 3, their distance from 0 is 3. Because distance cannot be negative. It doesn't have a direction. It's always just the amount or its magnitude. So distance should always be a positive number. Since absolute value is just the distance from 0, it should always be a positive answer. So knowing that, we're going to try to solve some of these. So you're going to solve absolute value or evaluate absolute value just like you do any other operation in math. So here I want to evaluate this expression, knowing that y is -3. So no matter what symbols you had seen, if I told you what one of the variables is, you would be plugging that number in or substituting that value in. So I'm going to substitute in my -3, and then I'm going to follow order of operations. It says to start with the parentheses. An absolute value is a type of parentheses, so I don't want to do the absolute value first, but I do want to do what's inside of them. So I'm going to 1.4 plus is going to stay. 5 times -3 is -15. Still inside my absolute value, I have -15 minus 7, which is -22. Now that I've done everything inside the absolute value, before I can try adding the 1.4 to this value, I need to actually evaluate that absolute value. So the absolute value of -22, where the distance from 0 on the number line, is 22. So I have 1.4 plus 22, which is 23.4. Next, we're going to look at actually solving. If you think back over here, very beginning, both of these, their answers were 3, but what was inside was either the +3 or the -3. So both of them had the same absolute value, which means that what's inside here, inside that absolute value, is either going to equal -5 or 5. So what we do is we typically split this into two equations. One where that x minus 18 equals the -5, and one where it equals +5, to represent both places on the number line whose distance from 0 is 5. And then you're solving these just like you've solved equations since Algebra 1. So I would add 18 to both sides. -5 plus 18 is 13. Over here, I'm also going to add 18. 5 plus 18 is 23. So my two answers are 13 and 23. With absolute value, it is absolutely crucial that you always check your solutions. So I'm just going to plug those back in. 13 minus 18, and the absolute value of that. The 13 minus 18 is -5. The absolute value of -5 is 5. So that one works. Over here, I have the absolute value of 23 minus 18. Doing my 23 minus 18 first, I get 5. And then the absolute value of 5 is 5, so that one works. So both of those answers would work. To show you with a number line just what this actually means, it means that some number is 5 spaces away from 18. So if I went 5 spaces, let's just go to the right first, 19, 20, 21, 22, 23. Yep, that's 5 spaces away. I want to go 5 spaces to the left as well, 17, 16, 15, 14, 13. So I get my two numbers that are 5 spaces away, or distance on the number line, from, in this case, 18 instead of 0, since it wasn't minus 0 or just the x, it was minus the 18. Here, when you're solving again, you're following just like you've always followed with solving equations. You do need to do this minus 9 first. And so then I end up with the absolute value of 5x minus 6 equals negative 9. At this point, I need to realize, though, that absolute value means distance on a number line. A distance can never be negative. So this is never going to be true. We're going to call this no solution. You may also hear it referred to as the empty set, but you will have seen no solution a whole lot more. Another example, I'm working on what is inside my absolute value has to be equal to either this or a negative version of this. So x plus 6 is going to equal 3x minus 2, or x plus 6 is going to equal a negative version of this. So in the past, maybe that was a 5 and we just had positive 5 and negative 5. But since there's more than one term over here, you are going to have to distribute that negative sign on that side. Over here, I can go ahead and get my like terms all on the same side. So I would probably subtract my x over to get 2x. And I would probably add this 2 to get 8. Dividing is going to give me x equals 4. Over here, before I can move things around too much, I do need to distribute this negative. So I get negative 3x plus 2. In this case, I'm going to move this negative 3x over to the left side, so I'll have to deal with that negative. Opposite of a minus is plus, so I'm going to add that and get 4x. Over here, I'm going to subtract my 6 to get negative 4, so I get x equals negative 1. Again, you do need to check your answers, so you want to plug them back in. So the absolute value of 4 plus 6, I want to know if that equals 3 times 4 minus 2. 4 plus 6 is 10, so the absolute value of 10 is 10. Over here, 3 times 4 is 12, minus my 2 is 10. They're the same, so both solutions work. On this side, the absolute value of my negative 1 plus 6, does that equal, I'm plugging it back into the original equation, 3 times that negative 1 and then minus 2. So negative 1 plus 6 is 5, so I have the absolute value of 5, which would be 5. 3 times negative 1 is negative 3. Minus 2 gives me negative 5. 5 is not the same as negative 5, so this solution does not work. X equals 4 is your only solution. You do need to show both, but X off the one that does not work.